was I confounded? I have time, all the time I need to put an end to you. Come to find me, to destroy the monster. I am real. No one. No one is safe.
All right, welcome back. Today we're going to continue where we left off, but just a reminder that if you plan on turning in for reconsideration assignment 1, 2, or 3, that is due by the 29th. So we need to have those in there and done by the 29th if you're going to choose to do one of those, or 2 of those, I guess, is what we were offering. So just to remind ourselves before we continue on what we were looking at, we were designing this database here. Let me zoom in a little bit, right? It was supporting our assets and stocks and, or I think annuities is what we were doing. And so we, of course, designed it to have a person table, right? Because a person can own multiple assets. And one asset, we redesigned it so that one asset could be owned by multiple people. So we have a join table in between here. And we've got a one-to-many relationship from the person table to the ownership table, and many-to-one relationship from the ownership table to the asset table. We bring those 2 things together with, remember, these are called foreign keys. So the little filled-in dots with the, or the filled-in diamonds, I guess, the red ones. A person ID refers to the person ID over here in the person table, and then the asset ID refers to the asset ID over here in the asset table. We also have an email table here so that one person can have multiple emails, right? And there is the foreign key over there in the child table. Remember, this is a parent-child kind of relationship. And we also took a strategy called a single table inheritance strategy. Remember that we had 2 types of assets. We had stocks and we had annuities. And we put those all into one big table, right? Using this column called type, called the discriminator column, to discern between whether or not it was a stock asset or an annuity asset. And that was just a single varchar, A or S, depending on the type. Then we put all of the things that were relevant to an asset over here, and then we rethought that design because we realized, I forget what example we used, but say LeBron James owns 1,000 shares of Google stock, and I own 100 shares of Google stock, right? We don't want the number of shares to be the same for all stock assets, right? So we decided, no, that doesn't really belong over here. So we moved it over here to the ownership table, and I left that as a to-do, an exercise for you, right? So to review what we did through that entire process, basically when you design a database, just like when you design classes, semantics dictate design. You're basically going to have one table per entity. If you have people, then there's a table. And people have emails and multiple emails. There's a table, right? Basically, the reason that we went with a upper camel casing on the table names and a lower camel casing on the column names is because you are going to have a one-to-one correspondence from from your Java classes to your SQL tables, right? Remember to be consistent with your naming conventions. And I was following those same naming conventions because using, say, tables, using upper camel casing, and columns should be lower camel case. Why? Because that's exactly what we use in Java, right? So no guesswork at all. That table and that Java class have a correspondence, and all of the variables and all the columns are named exactly the same, right? Avoid pluralizations, right? Abbreviations, etc. Right? Make sure that every table has a primary key. Remember that we shortened that to PK using an integer and a name that is the table name plus, or let's go with lower camel casing to be consistent about it, plus ID. So you just slap an ID at the end. Take a look at the pattern over here. If it's the person table, then it has a person ID. If it's the asset table, it has the asset ID, right, et cetera, right? And we're going to talk about why we do that for second normal form here in a second. Foreign keys should have the same name as the primary keys that they reference, right? This is because, it's easier to remember these things. Oh, there's the foreign key. What table does it reference? Well, because I'm following that convention all over the place, I know just from the name of the column itself that it is referring to the person ID in the person table, right? There is no guesswork here at all. Avoid strings, right? Strings should not be primary keys or foreign keys, right? But you can, in fact, should, in some cases, make a secondary key out of strings, right? For example, ISBNs. Is an ISBN a number? Not necessarily, right? Social Security numbers. Social Security numbers are numbers, but they also have dashes, right? So that's not that would also be a string. NUIDs, right? NUIDs begin with zeros. That's not really an integer, right? All of those things should have keys. You can place a uniqueness constraint, or or keys, key or index on columns. Remember the difference there. Uniqueness ensures that there is only one record with that value. So that if I have NUID 314 or 1234, whatever my NUID is, right? Then I put a uniqueness constraint on that. I am making sure that no other record in that table has the same value. So if you have a uniqueness on that, great, go ahead and do that. That's called a natural key. But don't make that into your primary key or foreign key, because you have no control over it, therefore it should not have control over you, okay? For the same reason that sometimes NUIDs are granted erroneously, right, to the same NUID to two people. One person gets two NUIDs. You don't want to have that mistake permeate throughout your entire database, right? But you can put a key or an index on it or a uniqueness constraint to ensure that it is unique. Or remember that the difference between keys and indices, basically maintain an ordering on that. If you're going to do any queries based on those two, on that column, you put a key or an index on it so that you can do something like binary search, which is exponentially faster than linear search. Okay. Join tables should be used to model a many-to-many relationship. Right? Be sure to put plenty of test data in your database, and that should be easy, right? Because you already have test data, right? You have test data in a CSV form. And guess what? Those same tools that we mentioned for CSV to JSON, CSV to XML, there's probably a CSV to SQL, right? That you can do 90% of the work and then just tweak it afterwards to get it to work with your actual database. Those same tools can be used to generate data like that. You could also use MySQL Workbench here like Excel. For example, if I select everything from person, I need to use my database first. There we go. There's all the people. Right? I didn't actually write out these birth dates for each one of these people. I just went ahead and manually entered them. For example, if I want another unique person here for, let's see, who should we do? Blake Snell. We're just signed, unfortunately, with the wrong team. I have no idea when he was born, so let's just go ahead and say 1980, 0101. There we go. Right. Now I've not yet added that to my database here. When I close this, it's going to give me the option to apply those changes. Right? So if you want to, you can go ahead and do this all manually using your IDE like this. Right? And now all those people will be in the database. There we go. Right? All right. So you can generate stuff using the tools that we've shown you. You can go ahead and manually write the SQL if you want. You can use a tool like MySQL Workbench. Right? So there should be plenty of test data in your database. Don't rethink it, or don't put too much thought into it. Just use the test data that you've been using up to this point. Right? Check and uniqueness constraints can also be used to enforce data integrity. Right? For example, if you've got a number of shares that should never be negative, you can put in a check constraint to ensure that that will never be negative. Right? That any attempt to insert data or update data to negative values will be rejected by the database. This goes into what are called the ACID principles that we'll talk about here in a second. Before we do that, though, let's more formally talk about that entire process of taking what was originally a flat file and separating things out into their own tables. Right? There is a formal definition for all this, right? It's called normalization or normal forms. There's first normal form, second normal form, third normal form. And yes, there are other normal forms, fourth normal form, Bacchus norm. We won't get into that. That's hardcore data, like temporal databases and stuff like that. But these normal forms build on each other. You cannot have a higher normal form, third normal form, without the lower normal forms. So if you violate first normal form, you necessarily violate third normal form. Right? What is each one of these? We'll start at the bottom. The first normal form is that each attribute, and when we say attribute, we mean column, right, in a table only has atomic values. In the context of this definition here, an atomic value is an indivisible thing, right? We know that atoms now in the 21st century, we know that atoms are divisible. You can break up an atom into protons, neutrons, and electrons, and even those you can break up into subatomic particles, etc. But the original Greek word atomic means indivisible. Right? It's helpful to understand that this simply just means that each column in a table represents one piece of data, an indivisible piece of data, one value. Right? So for example, a violation of this violation would be to store a series of emails as one column, right? One CSV column. Right? So for example, email 1 at foo.com, email 2 at bar.com, right? Email 3 at baz.com, right? If you just like a CSV file, right? The whole reason that we got into relational database management systems was to get away from that terrible formatting and all the problems that come with CSV data, right? That we already listed at the beginning. So if you're just going to go ahead and go back to that, all right, then why are you using a database to begin with? That's a violation of first normal form. It would also be a violation to store multiple columns instead of a proper one to many relation. Right? For example, column email, primary email, secondary email. What comes after that? Tertiary email, right? And then you finally run out of ideas, like what is the fourth one, what is the fifth one, etc. Right? Don't do that, right? If you only ever want to store one email per person and you don't want to support multiple emails, fine. That is a one-to-one relationship that should be collapsed into one table. But if you are storing any number of emails, right, 1, 2, 3, 4, 5, 6, etc., then you should not be doing this, because if you do this, and that's, you know, what if this one person over here has 4 emails, right? Then you're not able to model that data. What if this person over here only has 1 email? and you end up inserting it as the secondary email instead of the primary email, right? Now you've got confusion. What if they did have a primary email and a secondary email and a tertiary email at some point, but then they lost their their primary email, right? Does everything get promoted up, right? You've got these very weird rules that should not have to go into the database at all. So that's a violation of first normal form. Again, the best practice is to simply just separate everything into another table, right? Make sure that you define one-to-many relationships properly using a foreign key. And remember that the foreign key goes in the child table. FKs go in the child table, right? And remember that you cannot have orphans, you should not have orphans, and you cannot have children without the parent record. Likewise, if you're going to delete something, the children records need to be deleted before the parent record gets deleted. Right? Second normal form is first normal form, of course, because they build on each other. But no non-prime attribute, and once again, by attribute we mean column, right, is dependent on a proper subset of prime attributes, columns, right? So ignore this for now and just understand that having a primary key auto-incremented automatically gives you second normal form for free. This problem only comes where you've got compound keys. So for example, and this is something I've not shown you because, again, if we follow a correct pattern, you will not fall into this. But suppose that we had instead a customer ID, a store ID at which they purchased something, but then the store address as well. Now suppose the primary key is customer ID / store ID, right? i.e. a combination of the two. Now, we didn't do this because I said follow this pattern and you'll get second normal form for free, right? But if somebody did do something like this, then they would be risking violating second normal form. Why are they violating second normal form if they store the address? Well, the address, does that have anything to do with the customer? The store address, that is. Does that have anything to do with the customer? No. It only depends on half of the key, store ID, right? That's going to end up being a violation of second normal form, right? So it is often useful or necessary to have what are called compound keys, right? But they should always be secondary, right? Yeah, go ahead and make a key combination based on that. But do not use it as your primary key. Otherwise, you run afoul of second normal form, okay? All right. Basically, again, everything should be split out into its own table again, right? Why are you putting the store address in the store table? You shouldn't be doing that. You should be making another address table or something that can be used by people, et cetera, just like you do with your classes. Again, if you're following our rule of thumb up here that semantics dictate design and that one class means probably one table, you're probably going to have a better design. All right, well, what about third normal form? And we didn't see this too often, but sometimes we see this even in Java classes, where third normal form, it has to be second normal form and transitively first normal form. But the definition here is that no non-prime column, right, is transitively dependent on the key. Now what that means is, let's take an example from our asset management system over here. An annuity has a number of years and a monthly payment. And the total value of that annuity is the number of terms times monthly payment times 12 because there are 12 months in a year. Right? What if you stored all three of these things? Suppose that you stored all three of those. But now the monthly payment changes, right? For some reason. Is the total value still correct if one of those other values changes? No. This one is transitively dependent on these two over here. So do not store the total value, right? It would be a violation. A violation is that the total value is stored when it should be recomputed based on the other values, right? So it's not often that it comes up, but I mean, it's enough that you should not be storing that other value there. Likewise in your Java classes, if you've got like this get total value method like we did over here in the asset class, where is it? Where's that asset class? Here's the annuity, right? Did we store the value, terms times 12 times monthly payment? No. We recomputed it every single time. Now, granted, sometimes it does make sense to store it, right? Private double value, right? If, and only if, it is super complex or costly to recompute. For example, to compute that value, you have to go out and make an API call to Google, and it's costing you money to do that because you're asking what is the current share price of this stock over there, right? And you're paying for that API. And also that, making that call over a network is going to be very expensive computationally, right? Fine, make that call once and then store the value somewhere. In other words, cache it, right? But don't do that if it's trivial, right? Terms times 12 times monthly payment. The only time that you would ever want to store something that is computable from your other state is when it's extremely complex or complicated or costly to do that, okay? All right. So again, the reason that you don't want to do this is because it gives rise to potential data anomalies, right? If you change one value, it means that transitively dependent value is now wrong, out of sync, right? So don't do that, right? And here's the mnemonic device that I remember that I mentioned before when we talked about who created the relational database model. Every non-attribute, in other words, column, must provide a key, and every non-key column must provide a fact about the key, the whole key, and nothing but the key, so help you cod. Right? First normal form, second normal form, third normal form, right? You have to tell the truth, the whole truth, and nothing but the truth, right? That's where that comes from. All right, there's a lot more. This is not a database course, though. But there are some things that you should be aware of, right? For example, triggers. Triggers are event-based actions in a database. The typical use case that I've seen out of this is suppose that somebody comes in and updates their email or updates their name or something like that. You can create what's called a trigger that on update, change this column over here to have a timestamp of the last updated, right? You can have a last updated column. And the database will automatically update that so that you can always know when did this last change, right? Some databases do support that natively, that you can, like if you're paying enough for the database, you can go in and find out the entire history of the changes to every single column, every single record. You can roll them back if you want to, but you're paying big bucks for those. MySQL does not do that. But you can set up triggers to get something like that. You also have views, which are read-only tables in a database. Suppose that you had, social security numbers over here in this person table, but you didn't want to grant total access to an application to all of the data. You just wanted to print out their first name and last name and date of birth, and not their social security number. You can grant a view that allows somebody to query that table with only that subset of columns. In fact, you can create an entire query out of that to grant a view to do that. So you can bring multiple tables together. It could be read-only, so that I trust that team over there, I trust them to go ahead and insert data with their code, but that team over there, the Android team, I don't trust them. So I'm not going to allow them to write access. Instead, I'm going to give them read-only access because that's all they need, right? You want to be as minimal as possible, right? This is why network people get a whole bunch of flack, because they would rather shut off the entire network and firewall everything, right? And then only if there's a reason, open things up, right? And it's generally a good policy, but it pisses a lot of people off, right? Because then they can't do certain things. This is why we fight all the time to make sure that 3306 remains open. Remember 3306? That's the port number, standard port number for MySQL, right? If they had shut that down over networks, then you would not be able to access your databases anywhere, right? So we have to fight to keep those things open for educational purposes. Right? There are also things called temp tables, temporary tables, where you can create a transaction to make data processing easier. In fact, there are entire stored procedures, functions, right? You can have loops, variables, which are called cursors, right, etc. SQL can be an entire programming language. You can live your entire life in the database if you want to. If you are a DBA, you'd be doing that on a daily basis. And you would be writing SQL code to do a lot of this stuff using loops and using variables that can be set and accessed and stuff like that. You can write stored procedures, which are functions, right? Any other thing that you would do in a regular programming language, you can do in SQL, right? But we're not going that far because, again, this is not a database course. Transactions are an all or nothing thing that provides the ACID principles. Right? So what are ACID principles? Well, first of all, what's a transaction? A transaction is where you can group multiple queries together. So here, say I've got 3 queries. I execute the first query, that's fine. Second query, that's fine. Third query fails, right? If I had put that in a transaction and it's an all or nothing thing, then that means that the first 2 that were successful never even happened, right? The entire transaction happens or none of it does. The way that we've been using SQL up till now, every single query is its own transaction, and that's fine. But if you are trying to do more complex stuff where like there's 50 different queries, right? And they all have to go or none of them should go, then you would wrap that up into one transaction because then you would have the ACID principles. ACID is for atomicity, right? Consistency, isolation, and durability. Right? These are all things that transactions provide in an RDBMS, a relational database management system. Atomicity, just like we talked about before, an atomic value is an all or nothing thing. It's indivisible. Those 3 queries are all or nothing. Right? Consistency. Before the transaction and after the transaction, all of the database rules that you put in, the check constraints, the uniqueness constraints, that the child records exist and refer back to a valid parent, et cetera, all of those rules exist before and after the transaction. During the transaction, they might be violated temporarily. But after the transaction, you're assured that they all are correct, right? That all those rules hold. Isolation means that one transaction does not interfere with another transaction. So that if I'm doing I start a transaction based on one particular timestamp of a database, and you come in with your transaction and you start mucking with the data, my transaction never sees your changes, right? It's like the changes are happening in parallel, basically. And that's what allows multiple users to use an RDBMS at one time. Right? You also have durability, that if somebody kicks out the power cord and you start it back up, you have all the database rules that were, all the transactions that were committed before that catastrophic failure are there. Right? You're able to restore back to a state where all the rules are followed. Okay? So those are the ACID principles. One other thing that I will mention, because it'll often make you a hero, right, is soft deletes versus hard deletes. So a hard delete is when you actually delete something. Right? Let me come over here and remember that let's zoom in so that we can see it. There we go. So we'll select everything from person. I want to delete all those people. Well, first of all, am I going to be able to do that? Delete from person. Am I going to be able to run that query right there? Let's try. Right? Nope. Error code, you're using safe update mode. What does that tell you? Blindly deleting everything is not going to work. Right? All right. Well, what if I delete person where person ID is 1? That will work because I'm being more intentional about it. Right? But that is an all or nothing thing. That's a hard delete. There is no undo, there is no undelete, there is no restore, unless you have a database backup that you're restoring. Right? A soft delete is a little bit different. It involves defining an is active column. Right? That is true if the record is active, false if it's deleted, but it's not really deleted, is it? Right? All your queries are going to be select everything from person where is active is true. Right? Now you're only getting back the things that are active, right, instead of the things that are inactive. Right? Now, why would you want to do something like this? Because no matter what you do on the front end, you're going to have IDT 10 users. You've heard of that before, right? ID 10 T users. Idiot users, right? You can go ahead and put as much, checks and balances in your interface as you want. For example, I want to delete this record, somebody, your end user is doing. They hit the delete button. You have a pop-up that says, are you sure that you want to do this? This cannot be undone. Yeah, I want to do that. Click, 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 yes, yes, blindly clicking yes. And you can even put up another gate, roadblock and say, are you absolutely sure that you want to do this? Because it cannot be undone. If you do want to do this, type out your username as confirmation. They type out their username, hit yes. They call you up and said, I didn't mean to do that. Right? Well, I'm sorry, but that was a hard delete, right? Well, not if you did it as a soft delete. I can't tell you how many times I've run across this where this is a real system that I'm using, I'm actually going to put in soft deletes everywhere because that is actually going to face an end user that I don't trust. Because I can't tell you how many times people have come back to me and said, we need to undelete that, right? And if I have hard deletes everywhere, that means I'm going manually through a whole process of finding all those records in the database and restoring those particular records, right? Versus a soft delete, where you tell them, gee, that's going to be a lot of work, right? And you tell your boss, that's probably going to take me 3 days, right? So you go off and you play video games for 3 days, and you come back and say, well, actually, no, you'd only take 2 days because you want to be the hero. And after writing one single SQL statement, set is active to true, you come back and you say, well, I was able to work all day and all night, and also I'm billing you now for 9 hours of consultancy work. Yep, I was able to restore those records, right? Yay me, I'm awesome, right? Right? So those kind of techniques are very, very common, right? And as long as you don't have an engineering boss or a boss that knows about this kind of stuff, then you'll be good. But if you do, then, oh, too bad, right? You generally do want engineering bosses. Garmin is famous for that. Every single manager in the Garmin company is a former engineer. They don't hire business folks, right? They promote from within, right? So it's always better to work with other engineers, even if you can't get away with stuff like that, right? Good. All right. So those are soft deletes versus hard deletes. Do not think that you have to do soft deletes in your project. Right? It's not going to come up. That's going to be a YAGNI. Do you remember YAGNI? You ain't going to need it. Right? Don't worry about it for this, but you should understand that these things do exist out there. Right? And finally, the last tip that I'll give you is that generally, you want to use a single table inheritance strategy with databases, right? Versus OOP models. Right? That's the one that we used over here. We had this discriminator column that determined, is it an annuity, is it a stock, right? You don't want to get any more complicated than that, especially for this project. Again, YAGNI, you ain't going to need it. You ain't going to need to get any more complex than that. All right? Any questions about databases or SQL? Because, yeah, you'll spend some time over here in MySQL Workbench, but that's not where I want to be, right? I want to write code to automate all that stuff, right? Which means that we want to write code to programmatically connect to a database and process results, right? I can't tell you how many times I've asked for data from the university or from an employer or something like that, and they'll say, oh, well, we can go ahead and give you this Excel download option. Like, no, I don't want an Excel download option. If you give me SQL access, I can go ahead and write my own SQL queries and do all, which are far more powerful. Even better yet, I can write Java code to programmatically connect to your database, so I'm not always, oh, every Friday I have to download a new Excel file and then import it over here, right? No, I'm going to write a program to automate that kind of crap away, right? So that's what we're going to do. We're going to programmatically connect to a database to process our data. What we're going to do is we're going to do it in Java, right? And we're going to be using Jdbc, Java Database Connectivity API. Right? Remember that it's an interface. Do you remember the solid principles? S-O-L-I-D, excuse me. D is the dependency inversion principle. In other words, I'm not going to write, let me go ahead and close this. I'm not going to write code that only specifically connects to a MySQL database. MySQL connection, right? Equals make connection, right? This is not Java code, right? Suppose that I did something like that though, right? And I started writing and I started writing and I wrote, ultimately I wrote 10,000 lines that connected to a MySQL database, right? Now suppose that we want to switch over because Oracle is now being terrible and not letting us use MySQL for free anymore, right? I want to switch over to a Postgres database, right? Which is a true free and open source software, right? And actually much better than MySQL. I wish they would install it, but they don't. And so now what am I doing with my Java code, right? 10,000 lines, right? Dot, dot, dot. 10,000 locks. Are you familiar with locks? Lines of code, right? Oh, wow, you wrote 10,000 lines of code, right? Awesome for you. Actually, do you want to write lots and lots of lines of code? No, all right, here's a little aside. I think I've got it over here. Where is it? Yeah, fun. I love this. That was posted on Reddit a long time ago, right? So, how do you know that you're an experienced programmer, right? Well, if you're just beginning out, you're only writing 2 lines of code per hour, right? But then, as you get better and better, wow, you're writing 45 lines of code per hour. But then as you get really good, then you're writing only 2 lines of code per hour because you're being very thoughtful and very intentional about it. But super brain time, you're taking out garbage code, right? When you're good enough, you can say, no, don't need that, don't need that, don't need that. Or a list, and then you do a binary search in a list. No, if I had used a map from the beginning, those 10 lines of code are gone, right? And I'm just using a map now instead, right? So you don't want lots of lines of code. And you certainly don't want lots of lines of code that are necessary that end up getting thrown away because now you're going over to a Postgres database, right? Instead of MySQL connection, now it's a PostgreSQL connection, make connection. And I'm going to be changing 10,000 lines of code to do that. Nope. Dependency inversion, right? Remember the solid principles? D equals dependency inversion, right? Do not program toward a low-level module, in other words, SQL, MySQL. Instead, program toward an interface. There we go. Well, guess what JDBC is? It's an interface, right? So I'm going to program towards a generic database. I'm not going to tell it what database it is. Instead, I'm going to let Oracle take care of that for me, or I'm going to let Postgres take care of that for me. Let's go ahead and get started. Getting started is going to be downloading and installing the connector.j file for MySQL, right? So I'm just going to go ahead and do a quick Google search here. I'll keep that open for a second. MySQL connector.j, right? jar. Right? There it is. I will include that URL in the notes. There we go. There, it's over there, right there. When you download it, make sure that it's platform independent. Java's platform independent. That's why Java exists. They created Java to write it once, compile it once, run it anywhere that you have a JVM. Right? So it's already platform independent. If you're comfortable with tarballs, go ahead and go for that. But otherwise, zip files are probably what most of you are going to want to use. Do not sign up for Oracle spam. There it is. There's the zip file. Open it up, and the contents are going to look something like this. Right? That's the thing you're interested in right there. Okay? So let me come over here, and everybody should already have it. I don't, but let's go ahead and create a new folder, lib, short for library, and I'm going to cut and paste or copy paste this over there. There. Now I'm going to add it to my build path so that I can use it. Build path, add to build path. There. I'm ready to start writing JDBC code now. Right? That's all it takes. Now remember those 10,000 lines of code that I might have written towards one specific thing? Right? Well, what if I do want to change from a MySQL jar over to a Postgres jar? All I have to do is throw away this jar and drag and drop a new one in there. I don't have to change a single line of code anywhere. Awesome. Right? Okay, well, I want to connect to the database. So, what do we need to connect to the database? I'm going to go ahead and close this for a second. Let's go ahead and close all that. All right. And let's go ahead and create a new connection in MySQL Workbench. What are the necessary things that you provided when you connected to your database? Well, you got, if you want to save that connection, you need to name it. But you need a host, right? That host was what? CSE Linux 01.unl.edu. You need a username, which is your username. And then finally, you need a password eventually, right? So over here in Java, it's the same thing. String server URL is equal to, there we go. Actually, there's a little bit more to it than that, and we'll get to it in a second here. String username. Now my username is Seberg3. Your username is your username, right? Don't go using my username. String password. Remember when we told you do not use anything, if you do end up changing it, do not use anything that you care about? This is why. We're going to be storing our passwords plain text in your Java source code. I will see it, the graders will see it, your partner, if you're teamed up, will see it. Anybody that sees your code will end up seeing it, right? So don't use this password, the same password that you use for your banking or whatever. Use something completely different, okay? What's my password? I don't remember. And I don't want to show it to you because I don't want it on the live stream. So what I did is, over in another class, I have this database info that I'm going to go ahead and cut and paste there. There we go. Database info dot password. There. Gee, that seems like a cool pattern. What if I did that for the URL and the username? In fact, what if I did that for creating an entire connection? I would have something called a connection factory that is now worth bonus points, right? If I put that into another class. So I don't have to repeat this over and over and over and over again, right? All right. Now that URL is not exactly correct. We need to specify how we're going to connect to it. So you've seen it before because everybody here has gone on a web page. HTTPS, right? What does HTTPS stand for? No, isn't that like high school level computer literacy kind of course? But yeah, what? Oh, excellent. That's even better. Hypertext Transfer Protocol, and then the S stands for the secure socket layer, right? That you are actually, if you don't, then you connect like that, right? You're expecting a web page out of that. There's a protocol. There's a talk. The two computers are talking back and forth using a protocol. That's not our protocol. Right? There are many other protocols. Does anybody know any other protocols? Oh, SSH, good. Secure shell, right? Also on SSL. Over SSL, the secure socket layer. FTP? Anybody use FTP before? All right. File transfer protocol, or SFTP, secure file transfer protocol. SMTP? What about that? That's what all email is based on. It's simple mail transfer protocol, right? You can go ahead and write your own email client that will bounce stuff off of unsuspecting servers, and now you're a spammer, right? And you can send spam. We're not going to do any of those things. Instead, we're going to connect using Jdbc to a MySQL database. So we're going to need that, okay? Once we've got those three things, we can create a connection. I'm going to call it con, right? Actually, I'm going to leave it like that. Then I'm going to go ahead and make sure that I'm importing this. Did I call that SQL connection, MySQL connection? Did I call that a Postgres connection? No. What is it? It is a, let's get rid of all this stuff since we don't need it yet. There we go. It is a java.sql connection, right? It can connect to any SQL server at all, SQL Server by Microsoft, Informix by IBM, Postgres by Postgres, MySQL by Oracle, Oracle by Oracle, right? It can connect to any of those as long as you have the correct jar file installed, right? It's generic, it's just a connection. What type of connection? I don't know, I don't care, right? That's because I am programming to an interface. I'm keeping it general and abstract. Now to actually make the connection, we need a driver manager. get connection. We're going to let it do our work for us. Username, password. There we go. Now it's not compiling because it's complaining for a second here, but that's how you end up doing it, right? The driver manager, which is this jar file that's buried somewhere in that jar file, we don't care where it is, right? It gets loaded up automatically. Java takes care of that for us. It's going to give us a connection to this server using this username and this password. The reason that it's not compiling is because it's using those old school, very, very old school check constraints. You are forced to surround this with a try-catch. Right? Now, lots of stuff can go wrong here. Right? For example, I could shut off my Wi-Fi. I'm not about to do that. Right? But then that means that you could not get to the server. Somebody could kick the power cord down in Lincoln, right? And that server is no longer up. Right? You might misspell your username. You might not have the correct password. Can you reasonably recover from any of that stuff? Not really. Right? How can I write Java code here in Omaha to plug the server back in Lincoln? Right? You can't do that. So we're just going to rethrow this. Throw new runtime exception E. Right? Everything that could go wrong with a connection is just simply going to throw a MySQL connection, MySQL exception, excuse me. Right? All right. Oh, it's probably going to go wrong. Why? I misspelled my name. Yep. So what happens? Cannot load connection because of underlying exception, wrong argument, of malformed database URL. Oh, sorry. Darn. That's what. I also screwed that up because of copy paste. Right? You don't want : / twice. There we go. All right. That could go wrong. There. Access denied for misspelled name there. All right. Let me go ahead and spell my name correctly. Oh, wow, cool. Everything worked. Except that, remember with basic resources, this goes all the way back to C too. If you open up a file, you start processing that file, you fail to close the file, you're crossing your fingers that you're not corrupting that file. Right? 9 times out of 10, you'll be okay, but it's that 1 time out of 10 that you ain't okay. Right? What do you need to do to that file after you're done with it? You need to properly close it. Same thing, in fact, it's 100 times more important with respect to database connections. .close. What if you don't close that connection? And we'll talk about why it's not compiling here in a second. Same reason as before. Right? What happens if you don't close that connection? So, like a file, it's being held open, right? You're not really looking for database corruption because of, again, those ACID principles. You have some guarantee that things will go right? But what's happening is you are holding on memory on your own computer. That connection on the remote server is holding on to memory. You are keeping it open over a network. So a network connection is being persisted. In other words, you're wasting a lot of resources. In fact, if you waste enough resources, you're going to get yourself into trouble. Let me surround this with a try-catch first of all. Oops. Come on. Surround with a try-catch. And there's really nothing you can do if it failed to close. Right? Let me go ahead and not close that. And let me show you what happens if I try to do this too often. So for int I equals 0, I is less than 30, I plus plus. Let me open up 30 connections and not close any of them. Actually, let's start with just 29. 28, just to be safe. There we go. 1, 2, 3. Oh, okay, fine. Let's bump that up to 30 now. 1, 2, oh, 30 worked. Fine, 35. There we go. Max user connections. At some point you will run out of connections, right? I thought that I'm pretty sure that the max user number of connections is 30. You open up 30 connections, you try to open up that 31st connection, and this happens. Now you're waiting 5, 10, 60 minutes, a full hour for all of those connections to reset, and crossing your fingers that they gets done quickly, right? Because you have work to do, right? So don't do that. Make sure that you, well, first of all, don't needlessly open up 30 connections like that. But anytime you find yourself opening up a connection or another resource, immediately write code to close it. Right? Don't just write it and then do the stuff and then close it. Right? This is why when I teach file I/O, right? 1, open the file. Right? 2, to do, process the file. But immediately jump down to the end and close the file. Then go back and do the middle stuff. So you never forget to close your resources. Same thing, in fact, even more important here with respect to database connections. Because once you run out, you're waiting on the server to reset them all. Right? Let's see. Get rid of that. Get rid of that. I don't need that anymore. Let's try. Oh, that's why. It was allowing me 30 because I thought I was connected and I wasn't. Right? Let's open up that foo. Desktop. Foo. Oh, come on. Why aren't you open? All right, whatever. Use C3. Show process list. Process list is the connections that you have. So apparently I'm connecting from cberg7 at unomaha.edu through that port. There's another one, there's a second connection that's actually running that query that showed me all the connections. This is a persistent connection that is being kept open by MySQL Workbench. Let me show you once again that if you do this and you don't close it, in fact, let's do this, while true. I'm just going to go ahead and send it into an intentional infinite loop here that it never closes the connection. Let's go ahead and run this. It's running, infinite loop. Let's come over here and show the process list. There's my other query, or there's my other connection. It's only been alive for 4 seconds at this point. What is it doing? It's just sitting there asleep, right? Taking up resources, staying, keeping the network connection open, holding on to memory on both ends, just generally wasting time, wasting resources. Cross your fingers and hope that killing a program cleans it up for you, because one time out of 100 it won't, right? And you'll be stuck. Right? There we go. So that's opening a connection, that's closing a connection. Okay? So here's the full process. In fact, yeah, we're good on time here. Here's the full process. Oops. There we go. And there we go. Here's the full process. You create a connection to your database. You need the username, password, and URL. Right? You prepare your query, right? By preparing your query and then executing your query. If you are expecting results back, in other words, it's a select statement, you process the result set, the results. If it was an insert or update or destroy or delete, then you're not expecting anything back, right? You're changing stuff on the database. And so you would skip this third step right here. Then you make sure to clean up your resources. So just as an exercise here with the remainder of time that we have, let's go ahead and select everything from person. Right? I want to get all that people information out of the database, okay? So let's write our query first. I've already got the connection. I close it down here. Now let's go ahead and process it. So let's label this. 1, make your connection. 2, formulate your query. So 2A, right? Write your query. Query. There we go. And a query is just a string. And I'll call it query. That's query. Query, right? So if I were doing this in SQL, what would I want? I would want this. Select everything from person. In fact, it's usual to have 2 IDEs open at the same time, because I'm going to write my SQL over here, troubleshoot it, get it to a point where I know that it's correct, and I'm simply going to cut and paste it and bring it over here. Right? Looks nice. Strictly speaking, semicolons inside of the strings are not necessary, but be consistent. Here's a situation where you may want to reconsider that lowercasing. Right? Over here in this IDE, we have modern syntax highlighting. Over here, it's just a stupid string. Right? It's all blue. So if you want to offset the keywords, you can go old school on it and use all capitals for your keywords, right? Okay? This is bad practice. Don't do this star. We'll come back later on and fix that, okay? But there's my query. Now what I need to do is I need to prepare that. Prepared statement, PS, right? There's no better name for it. Prepared statement is equal to con.prepare statement. There we go. And there's my query. Now the prepared statement, come on. Import that from java.sql. There we go. Everything you do in SQL is going to have to be surrounded with a try-catch. At this point, I've got this thing in a try-catch. I'm going to have this thing in a try-catch. I'm going to have this thing in a try-catch. If you want, every single thing that you do can be in its own try-catch, try-catch, try-catch. Ugly, right? I don't want to do that. So what I'm going to do is I'm going to immediately have only one try-catch. There we go. And get rid of this up here. There we go. Reformulate everything, reformat everything, right? I'm just going to have one big try-catch because if anything goes wrong, right, I don't really care. I want it to be fatal, and I'm going to rethrow this exception, right, because something fundamentally went wrong with my code. All right, so why are we preparing this statement? What if you have things like, say, I don't know, a quote? For example, eventually we're going to insert stuff. Insert into person, last name, values. Let's go with, I don't know, O'Brien. There we go. There. That's how we do it in SQL, right? But what are the problems with the double quotes, first of all? They're unbalanced. So I'm going to have to go through manually and go escape, escape. Such an arduous process, right? Whereas if I use a prepared statement, it'll take care of that stuff for me. Not only that, but what about that single quote? That single quote also needs to be escaped. Right? I don't want to have to think like that. I don't want to have to do all that manual labor myself. So I'm going to let a prepared statement do it for me. In fact, it's absolutely, from a security point of view, it is absolutely necessary to let your prepared statements take care of this stuff for you. Otherwise, you open yourself up to what's called an injection attack. We'll talk about that later. Right? So there's my prepared statement. Now I'm going to go ahead and create a result set. RS is equal to ps.execute, execute statement, execute query. There we go, execute query. I just need to import this now. Right there. So I'm creating my query, preparing it so that if anything that needs to be escaped is properly escaped, and then I'm executing my query, which gives me a result set. Why? Because I need a select statement. It's a select statement. I expect something back. Right? Just like over here, if I execute select everything from person, there's my result set right there. Okay? Now the way that this works is really, really old school. Right? It is basically a table, right? And there's a pointer into this table. Initially, that pointer is pointing before the first element. So I need to go ahead and process this as a set. So while rs.next, right? Or to do, process the current record, records, columns. There we go. What is this rs next doing? It is iterating through these. There are 4 people in my database. Initially, that pointer is pointing before the first one. rs.next. The question is it pointing to a correct person, or to a legitimate person, legitimate record? Yes. rs.next. Is it pointing to a legitimate record? Yes. Next. Is it pointing to a legitimate record? Yes. You're still in the loop. Next. Is it now pointing to a legitimate record after those 4 records? No. That's where it breaks out of this while loop. rs next advances the pointer to the next row. while at the same time returning true. Yes, I'm pointing to a correct record. Or false, I'm not pointing to any record at all. Right? Once it's false, it breaks out of this loop. Right? So let's process each column. Right? The current record is already pointed to by rs. Right? So all I need to do is rs.get. And let's see, we want the first name. What was in there? The person ID. Let's get the person ID. Dot get person ID. I put in the column name, but now I need to specify, well, how do you want to get it? Right? What should be coming out of the database if I'm getting a person ID? What type? Is that a string? Is that a double? Is that an integer? Integer. So get int. Right? Int person ID is equal to. There we go. Now I've got that person's ID. If I want their first name, that's a string. First name is equal to rs.get. Well, that's a string, so first name, there we go. And last name, and there we go, there we go. What else was in there? Date of birth, which is also a string. Date of birth. Date of birth. In fact, I'm going to call this date of birth str because I'm immediately going to change that into a local date. Date of birth is equal to local date dot of, and then date of birth as a string, str. There we go. Come on. Oh, of doesn't work. How have we been doing local dates? Dot parse. There we go. All right, let's print all those things out. System.out.println. Actually, no, let's not print them out. Let's actually create a person from that data. Person P is equal to new person. Right? Last name, and how can I create a new person? Let's see, last name, first name, and then date of birth. So last name, first name, date of birth. And then system.out.println P. Let's run this and see if it works. Oops, what's wrong? Oh, first name. I never did the first name? I deleted it apparently. Okay. First name, first name. There we go. Run it. What's wrong? No database selected. Sorry. So no database selected. In MySQL Workbench, what would we do? We would use cberk3. We don't have to do that over here. We just put it into the URL. There we go. That's how you specify your database. There we go. There's me, Babe Ruth, LeBron James, and Blake Snell. Right. Why is it not printing out their date of birth? Well, I didn't do the toString method that way. Right? Where's the person class? There we go. There's the toString method. All it's doing is, where is it? All it's doing is last name, comma, first name. If you want if you want a different behavior, then you need to do that different behavior. Now wait a second. Before we go to lab, what didn't I use here? In fact, it's warning me about it. Person ID. Well, now that my objects have a connection to the database, maybe I need to redesign them a little bit because I do want that information. Why? Because I'm going to be using that as a foreign key to get their emails. I'm going to be using that as a foreign key to assign them assets. I'm going to be using that as a foreign key everywhere. So I want that information now. Right? Fine. Do I have to rewrite my entire class? No. Keep what you want. Add what you want now. So int person ID. In fact, I'm going to change that to an integer. And I'll justify that here in a second. Right? Private, final, integer, person ID. Right? So that this dot person ID is equal to person ID. There we go. Right? Why did I make it a big I integer? Because my other code still creates people that don't have a connection to the database. Right? I still want to retain that functionality. So I've given myself two constructors. One way that you can create it with no connection to the database whatsoever, And the other way, you connect, you pull it out of the database and everything is specified, including the ID. Well, that does break this constructor down here. So what can I do? This person ID is equal to, well, if it has no connection to the database, what would be an appropriate value? I thought I heard it. It could be 0, but 0 might actually be an ID. Right? Null. Why? Because your primary keys will never be null. Right? Remember, that's how we define them. Primary key, not null, auto increment. Right? And nothing else was broken. Right? And now I have a way of creating people that have a connection to my database. The only other thing that I'll say before we go on, continue next time is, that seems like a lot of boilerplate, right? Just person ID, last name, first name, date of birth, date of birth. There's got to be an easier way, and there is, but it goes beyond the topics of this course. If you're really wanting to learn about a better way of doing this without having to write a lot of code, your solution is JPA. It's Java Persistence API. Right? Example? I've got examples. If we have enough time, we can look at it. I don't want a JPA query. There we go. Here's a good example right here. Right? So instead of writing Jdbc code, what you do is you annotate your classes. I'm going to say that this is an entity. This thing is my ID, my primary key. It's auto-generated, and it's not nullable. That sounds really familiar, right? When you write your SQL code, I wrote person ID not null, int not null, int long not null, auto increment, et cetera, et cetera. Here are the equivalents in annotations. You do that for all of your columns, right? That the seat number is going to have a column, and it's the same name in the database. There is a passenger table in the database, right? And so what you can end up doing is you can just say, I don't want to write a single line of Jdbc code. I want you to load this stuff up for me. And you can. Ignore all that. Okay. This is way too complex here. But basically, you can get away with it without having to write a lot of code. But that goes beyond the scope of this course. If you want to learn JPA, be my guest. I'll even help you. But get your Jdbc version done first, right? Because it's a lot more straightforward. Yes, it's a lot of boilerplate code. It's a lot of code, but it's dumb code, right? It's easy code. Right? All right, we'll pick it up there on Thursday. There we go.